In this video of the booster compressor maintenance and operation series, we will be reviewing booster compressor components.
Booster compressors are complex machines with dozens of individual parts. Familiarity with these components is essential for operation, maintenance, and troubleshooting of the booster compressor. In short, understanding the components and functions of the booster compressor is critical for its safe, effective, and sustainable operation. This is an overview of the RICS 2PS booster compressor, a widely used model in smaller PSA plants. It has two stages as shown by the pressure gauges on the top of the machine. Pause now to familiarize yourself where each part is located. You may return to this point at any time. Likewise, this is an overview of the Biolon GOW15 booster compressor. It has four stages as shown by the pressure gauges near the middle of the machine. Pause now to familiarize yourself where each part is located. You may return to this point at any time. Let's review some of the key components common to most booster compressor models in a bit more detail. Pressure relief valves protect the booster compressor from dangerously high pressure levels. Pressure relief valves automatically open when the relief valve setting is reached. Oxygen is vented until the pressure returns to safe levels within the booster compressor. The ideal pressure range and relief valve setting for each stage of the RICS 2PS is shown here. The margin for error differs for each stage, but all have a maximum pressure setting above the ideal pressure, where the valves will open and prevent pressure from further increasing. The pressure relief valves are located before and after each compression stage. As shown here, pressure relief valves can typically be found behind their corresponding pressure gauge. The drive belt connects the motor to the crankshaft. It transfers energy to the crankshaft that will drive the piston's motion. Inspect the drive belt regularly to catch any signs of damage. Slippage, wear and tear, or incorrect tensioning will reduce energy transfer efficiency and decrease the performance of the booster compressor. The crankshaft drives the connecting rods, which in turn move each stage's piston up and down. The pistons increase oxygen pressure by moving within the sealed cylinder housing. Each piston works on the same principle but is sized to match the pressure and volume requirements of its stage. When replacing a piston, pay close attention to its orientation. Incorrect orientation will prevent proper function. Pistons in an oxygen-rich environment cannot use oil as lubrication due to the high fire risk. Instead, each piston uses rings to reduce friction, seal the cylinder, and prevent gas leaks. In most cases, there is a rider ring at each end of the piston. These are wide, flat rings with a diagonal slit. Compression rings have a sharper diagonal cut and are used with a backing O-ring behind them. Rings wear quickly and must be replaced regularly to perform maintenance. The cylinder housing is the chamber in which the piston moves and compresses the oxygen. It also contains the intake and discharge valves that control oxygen flow. Cylinder housings vary in appearance by compressor type. This slide shows examples from Biolon GOW15 and RICS 2V3B model cylinder housings. One-way valves stop oxygen from flowing backward in the system. Valve design varies by stage, model, and manufacturer. The four examples on the right are circled in green. The top example is from a RICS compressor and uses reed valves. The bottom diagrams are from a Biolon compressor. All valves have a suction side and a discharge side. One side of the valve will allow oxygen to flow in, the other side will allow oxygen to flow out. Orientation of the valve is critical during replacement. Incorrect orientation will prevent oxygen from flowing through the stage. Servicing the cylinder housing is a complex process due to the number of parts which need to be placed in an exact assembly order. For more information on valves, see the resource Quick Service Guides at bhioxygen.org. Compression generates significant heat. Oxygen must be cooled between stages to prevent high temperatures. Cooling not only improves efficiency, it also protects the parts and you, the user. After each compression stage, the oxygen leaves the discharge side of the cylinder housing. It passes through cooling loops to passively cool the air over the large surface area. Some boosters will assist this process with the use of a cooling fan. The oxygen then enters the next stage through the intake side of the cylinder housing. Booster compressors are complex machines with many interconnected parts. Understanding each component's function and role is essential for effective maintenance and operation.
We hope that you have enjoyed this introduction to booster compressor components. Continue on to learn more about booster compressor controls.